Okay, so for number 17, it's asking us whether these statements here are true or false. And I've divided it into two parts because basically from A to F, we can see that we're dealing with essentially the same set everywhere, right? These are all the same set. So to answer this, first I'm going to find that power set. I'm going to say that X, I'll define it to be the set this and then that. So I've just called it X for brevity, so I don't have to keep repeating this. And so the power set of X is going to include all these subsets, right? So the first thing that's going to have is going to be the empty set, because the empty set is an element of every power set. And then we're going to have the set containing the first element, so the set containing the empty set, and then the set containing the second element, which is this, so the set containing this, right? And then the third element is just going to be X itself, so it's just going to be the set containing the empty set, and then this, and that closes, yeah. So we can see here that we do have, this power set has 4 elements, so that's element 1, 2, 3, and 4. So let's determine if these are true or false. So for A, it says that the empty set belongs to the power set, and that's true because we can find it right here. So, oops, that's going to be true. And then for B, it says that the set containing the empty set is an element, and that's also true because we can find it right here in the list of elements. So that's true. For C, we have that the set containing the set of the empty set is an element, and that's also true because we can find it right here. So that's going to be true. Then let me just erase these lines so that it's easier to follow. And then we're going to have the empty set is a subset of the power set, and that's true because the empty set is a subset of every possible set. It doesn't matter if it's a power set, if it's a normal set, the empty set is still a subset of every possible set. And then for E, it says that the set containing the empty set is a subset. So remember that for it to be a subset, it means that every element in the first one has to be in the second one. So the only element in the first set is the empty set, and we can find it right here. So every element in this is contained in that, so that fits the definition for subset, so that's true. And then the set containing the set of the empty set is a subset. So similarly, this has one element, that, and if it exists in the power set, then that's true. Well, it does exist because it is right here, so that's going to be true. So that's it from A to F. And now let's do from G to L. So 3 is an element of the rational numbers, and that's true because 3 is in the rational numbers. So that's going to be true. And then let's see. It says that the set containing 3 is a subset of the power set of Q. And for it to be true, it would mean that 3 is an element. It would mean that 3 then belongs to the power set of Q. That's what it would mean. But that's not true because the power set of Q only has sets for elements. So that's not true at all, right? Because 3 is not contained in the power set. Instead, the set containing 3, that is an element of the power set of Q. But that's not what it's asking us. So that's going to be false. That's going to be false because the power set only has sets as elements. And I is now going to be true because the set containing 3 is an element, right? Because the power set of Q contains all the subsets. So that's true. For this to be a subset, it means then that this element has to be in the power set of Q. And it is true because we do know, we've just said that, hey, this belongs to the power set of Q, right? So if every element in the first is contained in the second set, it means that it is a subset. So that's going to be true. So let's see. The set containing 3 is a subset. So for it to be a subset, it means that this element, it means that 3 belongs to Q. And that is true, right? Because 3 is indeed a rational number, so that's true. And for the last one, we have that the set containing the set of 3 belongs to the power set of Q. And that's not true because the power set of Q is only going to have, it's going to have the set 3, and then it's going to have the set, say, 3, 4, and then it's going to have minus 2, 3, and so on, but it's not going to have the set of 3. That's not going to be in the power set of q. So that's going to be false. And that is it for number 17.